Yes, good day, viewers. Good to have you here again. Uh, I want to take the second method to the first, the other video that I did the other time, talking about the same topic, but another approach this time around. We'll be talking about the derivative of the logarithmic function, and we are going to use another method this time around. So let's just go straight into it. The first example, as we treated the other time, says we find the derivative of y equal to in ln x squared, and we're going to make use of this table that we have here, the standard derivative for for the function of x. All right. Now the particular one that I'm going to use, these two are the ones that I'm going to focus on as they are important to the questions at hand. So now, if you look at the first question that we have, and you look at the table at the same time, you will realize that the item number 5 that we have here is the one that is suitable for use in this case. So we are going to be using the one that I marked just now. That's number 5. So if you look at it very well, because you have ln, this one is having ln, that is ln, and this one is also having the same thing. But the only difference is that this is x squared and the one that we have here is x. But there is no problem, there's a way around it. So we have y equals ln x squared. Now this is actually function of function. You can treat this as function of function. And so I will let u be x squared. Let u be x squared. So in that case, I will rewrite my y as y equals ln u. So in this case, I will, as you all know, when we have this as function of function, we make use of chain rule. We make use of chain rule that says if you have okay, let me take the derivative of u first. We have du dx. We're going to differentiate u with respect to x first. Then we have in this case we have 2x. Then we are going to do the same thing for y. We are going to differentiate y with respect to u. Right? So we have dy du will be equal to. Now if you look at this very well, look at the table. When you have ln x here, you are having 1 over x as the outcome. So in this case as well, as we are having ln u here, we have 1 over u as our outcome when we take the derivative of y with respect to u. So in that case, we are going to take the chain rule, which says dy dx will be equal to the y du multiplied by the u dx. So in that case, we have we substitute our values because we have previously obtained du dx and dy du. So therefore, we have this to be equal to our dy du is 1 over u. So I have 1 over u multiplied by du dx is 2x. I have 2x. But meanwhile, we know that our u was represented as x squared. So I will replace my u here as x squared. So I have 2 multiplied by 2x multiplied by 1 is 2x. Then I have u multiplied by 1 as u. By replacing my u, I have 2x over x squared. Okay, so the denominator can be expressed as this, we have 2x. You know your x squared is the same thing as x multiplied by x. So that will give us the privilege of taking out one of these x's that we have. So we have our final answer here is 2x. So that is the end of the first question. All right, so we move to the next one. Example 2 quickly. Now we have y equals to log 4x minus 1 base e. Y equals to log 4x minus 1 base e. So I have to take the derivative of this function. Alright, so we are going to consider our table again. And if you look at the table, it appears like as if we are going to make use of number 6, but that's not true. We are not going to make use of number 6 because we are having natural log here and we are having log x base a in this place. Why this one is to base e, so we are not going to use that. But by the time I will write this one. So by the time I write it, you will see clearly the one that you are supposed to use. So I have log 4x minus 1 into brackets base e. Okay, now you should not forget, you should recall that when you have log x base e, is still the same thing as you have the x. Okay, so therefore I can rewrite my y as ln 4x minus 1. Okay, I have replaced log to base e with ln. Okay, so therefore you can now go back to our table and see clearly what you can use. So if you look at it very well, you can see that it is still item 5 that is suitable for this question. So I will proceed from there, okay, by representing my by replacing 4x minus 1 with u. So I say let u be equals to 4x minus 1. Okay, so that will prompt me to write my y. Okay, my y will now be written as in u. So because I'm going to use chain rule, I will take the u dx, okay, in this case, which is 4, and I'll also take the y du. Now if you go back to that table, you see what the outcome will look like. Look at this. We have ln x, the derivative is 1 over x. Then we have it as ln u, the outcome, the derivative will also be 1 over u. So that is how it works. So now I will have my chain rule now. We have dy dx will be equal to dy du multiplied by du dx. So in that case, I will have what's my dy du? Dy du is here, okay, and it's 1 over u. So I'll write 1 over u multiplied by what's du dx? Du dx gives us 4. I'll put that as 4 over 1. Then 4 times 1 is 4 times 1 is 4, and u times 1 is u. But don't forget that we actually represented our u before now. We represented it as it was represented as 4x minus 1. So I will replace u with 4x minus 1. So I have 4 over 4x minus 1. So with this, I have come to the end of question 2. So let's go to question 3 quickly. Let's check question 3. Okay, question 3 says we should differentiate y equals to log 3x squared plus 4x is 10. Right? So we are still going to make use of that standard derivative from the table. So we have y equals log 3x squared plus 4x into brackets and base 10 is 10. Alright, so like I said in the previous video, when you have log to base a, I said the other time that our a can represent a particular number, whole number especially. So you have in this case, in the case of this question, we are having log to base 10. So our a is represented as 10. Okay, so wherever I see a in the table, I'll put 10 instead. So let's go. Alright, so we will do our representation again. Alright, I have y equals log u by representing this to be u. Let me write that. So I'll just say let u equals 3x squared plus 4x. Okay, so I will rewrite my y as y equals log u is 10. So let me take the derivative of this with respect to x. The u, the x will give us 6 because these two will come down here. Okay, and you still use it again by removing one from it. So we have 3 times 2 because the 2 is coming down to meet the 3. So that will be 6. Then you have x. These 2 that you have here, remove one from it. That is x raised to the power 1. So you have plus 4 because this is raised to the power 1, and 1 times 4 remains 4. Then you have x raised to the power 0 because 1 minus 1 will give us 0 here. So we have x raised to the power 0, which is 1. So therefore this one remains 4 because what you have is multiplied by 1, and 4 times 1 is 4. So in that case we continue. So that's the derivative of u with respect to x. So we take the y, the u. Okay, now if I come back to this place, I'm going to make use of item 6. So we have when we took the derivative of this, right, the outcome of this derivative of this function is 1 over x in a. 1 over x in a. So we have to do the same thing here. We have 1 over u in 10, because our 10 now is the one standing in the position of a. Therefore we are going to put in this place, instead of a, we are going to put 10. So that's why we have 1 over u in 10. Okay, so now we are going to write our the chain rule, dy dx equals dy du multiplied by du dx. So in that case, what's dy du? We have 1 over u mean, right? 1 over u in 10, okay, multiplied by du dx is 6x plus 4 over 1. So if you multiply, you have 6x plus 4 all over u in 10. So in that case, we go back to check our u. Our u the other time we represented that's 3x squared plus 4x. 3x squared plus 4x. So we have 6x plus 4 over 3x squared plus 4x into bracket the what? The 10. Okay, this is our final answer for the total. Now the last one, we have this question. Okay, it says we should differentiate y equals to the square root of 7 plus x. Okay, so in that case we can rewrite this as y equals 7 plus x all raised to power half. If you remember your indices very well, all raised to power half. So because we are dealing with log, if you check the law of logarithm, when we have, if you have log x raised to power m, okay, let's say this is the natural log of x raised to power m. I can write that as x raised to power m. Now whatever thing I do here, I can do here as well. So I can bring this n to the back here to come down. So I will do the same thing here. The n will come down. So I will write the n here. So you see the same thing. So in that case, judging from the law of logarithm, we are going to have this to be written as y equals to 1 over 2 mean 7 plus x. Okay, so this has made our work to be a bit easy because we are going to focus our attention on this alone now, because our half that we have here is a constant, so it's not going to disturb us in any way. So we're going to keep it constant. Okay, it's a constant. So looking at this, I can rewrite this one by let u be equal to 7 plus x. So by doing that, I can write y to be equal to half u. Okay, so if you look at the table again, you notice that the one that is suitable for us to be used here is item number 5. Item number 5, this one. So we make use of that while we are differentiating y with respect to u. So let's take u with respect to x first. We have u dx will be 1, because if you differentiate 7 as a constant is 0, then if you differentiate x, that will be 1. Okay, so if you take the derivative of y with respect to u, in this case you will have, don't forget that you have half. Write that one down, it's a constant, write it down. And you have then u, which is according to the table, then x is 1 over x, Therefore, the u will be 1 over u. So multiply by 1 over u. Okay. So and this will give us 1 over 2 u. So let's take the formula now. For chain rule, we have dy dx equals to dy du multiplied by du dx, and this is written as, now what's our dy du is 1 over 2u multiplied by, what's our du dx, that is 1. So I'll write that as 1 over 1. So in this case, all I will have at the end of the day is 1 times 1 is 1, 2u multiplied by 1 is 2u. By replacing u, replace u which is this previous value, that's x plus, 7 plus x, 7 plus x. Therefore, I'll have this to be equal to 1 over 2 bracket 7 plus x. So this is the final answer here. And with that, we have come to the end of this video. I have left an exercise for you to check. You can try this out and can tell me, give me the feedback in the comment section. If you have any concern, let me know. Thank you for your patience. I'll see you in the next video.